Most of you probably already know that in order to take a derivative, you need to put the exponent before the x, or the constant if there is any, and subtract 1 to our exponent. If you didn't know that, then you're welcome. So if we have something like 2x to the power of 3, then our derivative would be 6x to the power of 2. But what should we do if we have something like this, or that, or even that? Well, let's get to that after the intro. So first things first, there are two ways to get the slope. You can either take 2 points and then take the slope of a secant line with the formula y2 minus y1 divided by x2 minus x1, or you can get the instantaneous rate of change of a single point, which you can also view as the slope of a tangent line. So we already discussed how we take the derivative of a basic function to get the instantaneous rate of change. But what if our function looks like the following? In order to take the derivative from a root, you basically just need to transform the square root into 1 over 2 and then take the derivative. And if you have something like the third root of x, then you can simply transform it into x to the power of 1 over 3. And if you have something like the fourth root of x, then you can transform it into x to the power of 1 over 4. Now let's say we have an exponent inside the root. How would we solve it? Well, you can rewrite it as a fraction again. So in that case, the 4 would be the numerator of the new exponent of x, and the 7 would be the denominator. So we get x to the power of 4 over 7. And then you just take the derivative from it. Now let's talk about trigonomic functions. Okay, I'm just going to be brutally honest with you, you just need to memorize this. If you want to, you can take a screenshot. Trust me, you just get used to it. Now let's quickly talk about Euler's number. So if we have something like the derivative of e to the power of v, then we just simply get e to the power of v times v prime. So if we get e to the power of x, then the derivative would simply be e to the power of x. Damn, how convenient. I love that Euler guy. Now let's say we have e to the power of 4x squared plus 2. If you want to, you can pause the video and solve it for yourself. Well, the answer would be 8x times e to the power of 4x squared plus 2. Yeah, I think if I'm ever going to make merge, I'm going to put Euler's number on it. Now let's talk about natural logs. So if we need to take the derivative of L and U, then the derivative would simply be U prime divided by U. So if we had ln x, then the derivative would be 1 over x. Because the derivative of x is 1. Now let's say we have something a bit more complicated. Let's say we need to take the derivative of a natural log of x squared plus 5. If you want to, you can pause the video again and solve it for yourself. But that's the answer. Now I also made a video about what the integral symbol actually means, so you might enjoy it as well. And it's a bit sarcastic.